For this problem, we're told that aqueous lithium iodide and aqueous silver nitrate react to form solid silver iodide and aqueous lithium nitrate. We're asked to write the complete balanced equation, the complete ionic equation, and the net ionic equation. Let's start with writing at least a skeleton equation. They changed the formatting. Okay, so we have lithium, lithium iodide. Those both have lithium has a charge of +1, iodine has a charge of -1, so it's Lii, which is aqueous. Let's try this marker instead. Reacts with aqueous silver nitrate, Ag. Silver has a charge of +1, nitrate has a charge of -1. It's AgNO3. To form solid silver iodide, it'll be AgI, which is solid, and aqueous lithium nitrate, LiNO3. All right, we have a skeleton equation here, and we had to check if it's balanced. We have one lithium on each side. We have one iodine on each side, we have one silver on each side, and one nitrate on each side. So this is already balanced, so that is our complete balanced equation. Now I have to write the complete ionic equation, and to do that we're going to take anything that is aqueous, any of those aqueous compounds, and split them up into their anions and cations. So lithium is a cation, silver is a cation, and then our anions are going to be iodine and nitrate. Silver iodide will not get split up into ions because it's a solid. So we have, look, I keep color coding this. Lithium, which is a +1 ion, it is aqueous. And we're going to add that, or we're also going to have iodide as a -1 ion, also aqueous. So just split these up. Now we're going to add our silver, which is +1 and aqueous, and our nitrate, which is -1. We have to include the charges of the ions in our complete ionic equation. And then that is going to react to form, I'm going to have to go down to the next line here. Silver iodide, which does not get broken up into ions because it is a solid. And then we have lithium, which again is +1 and aqueous, and nitrate, -1, which is aqueous. So if we did our balancing correctly on the complete balanced equation, then our complete ionic equation will be balanced. So here's our complete ionic equation. It has everything that is aqueous broken up into ions. To figure out the net ionic equation, so this is a complete, next we need the net. We need to cancel out all these spectator ions. The spectator ions are going to be the ones that are not doing anything. That is, they're in the same form on each side of the reaction. So lithium +1 is right here, but it's also right here, so we can cross it out from both sides. Nitrate -1 is here, but also here, and we can cross it out from both sides. You can think of this in algebra as we're subtracting lithium from both sides, or we're subtracting nitrate from both sides. But we can't do that to silver or iodide because they are in a different form once they're in a compound. So we're going to write this all as we're going to write what's left over. So we have our iodine ion plus our silver ion reacting to form silver iodide. And this is our net ionic equation, because it's what is left over from the complete ionic equation after we've subtracted off the spectator ions. So the complete ionic equation minus spectator ions will equal your net ionic equation. Now this reaction doesn't show what we do with coefficients or with subscripts, so let's have an example that does that. Let's say we have this will work well. I'll just write the whole thing up. Let's say we have HI, that's hydroiodic acid, I think. Let's say it's aqueous. And it's going to react with lithium sulfide, which is also aqueous. And that's going to react to form hydrogen sulfide, which is a gas, and lithium iodide, which is aqueous. Now, if we want to write the complete ionic equation for this, we're going to have to be careful in breaking up our ions. So, this 2, that is a coefficient, applies to both the hydrogen and the iodine. Same here. We have 2 lithiums and 2 iodides. But the 2 that is a subscript here only applies to the lithium. Hydrogen sulfide is not going to get broken up into ions because it's a gas. Only aqueous things get broken up into ions. So our complete ionic reaction, or complete ionic equation, would be 2H plus 1, aqueous, plus 2I minus 1, aqueous. Again, the 2 carries through. Now, this 2 that is a coefficient here is going to become, I need to finish this video quickly. This 2 that is a subscript is going to become a coefficient for the lithium. So we have 2 lithium ions, aqueous, but we only have 1 sulfur ion, and that's minus 2 charge. It's aqueous. I'm going to go down to the second row. Normally we'd do this all in one row, but there's not room on the screen. Then we have our hydrogen sulfide, which, because it's a gas, does not get broken up. And we have our lithium iodide. So, sorry, this is a complete ionic equation. We need to break it all up. We have our 2 lithiums, which are plus 1 charge. And we have 2 iodides, which are minus 1 charge. And from here, our complete ionic equation, we go about this the same way as before. We cross out our spectator ions. So we have a lithium on each side. In fact, we have 2 lithiums on each side. And we have 2 iodides on each side. So our net ionic equation would be 2H plus 1 aqueous plus sulfur minus 2 aqueous reacts to form H2S gas. Hope this helps.